but because its light is smeared so delicately across the sky. The central bulge and bar are visible, but its true dimensions only emerge in deep long-exposure observations, revealing an immense disk that contains a faint spiral structure. Malin 1 belongs to a class of galaxies known as low-surface brightness galaxies, LSBs. These galaxies defy the classical expectations of star formation, as their gas densities are too low to easily trigger the gravitational collapse required to ignite star birth on a grand scale. Yet Malin 1 contains a massive dark matter halo that helps maintain its stability. It rotates with surprising coherence, suggesting that despite its ghostly appearance, it is dynamically mature and gravitationally bound. The faint spiral arms of Malin 1 hint at a complex evolutionary history. Some researchers speculate that it formed in relative isolation, avoiding the interactions and mergers that typically stimulate bursts of star formation in more luminous galaxies. Others propose that its faint disk was built up slowly over cosmic time, fed by cold gas accretion or minor mergers that preserved its delicate structure without igniting dramatic starbursts. Either scenario paints a picture of galactic evolution that is far more subtle and extended than the violent histories of brighter galaxies. In ultraviolet and radio wavelengths, Malin 1 reveals more secrets. While the optical image suggests dormancy, other parts of the spectrum hint at ongoing, albeit inefficient, star formation. The neutral hydrogen envelope enveloping the galaxy is immense, extending even farther than the visible structure. This reservoir of gas suggests that Malin 1 could, under the right conditions, awaken into a more luminous phase, though for now it remains in a low-energy slumber. The study of Malin 1 offers valuable clues about the dark sector of the universe. Since much of its mass is non-luminous, dominated by dark matter, it serves as a natural laboratory for understanding how such halos influence galaxy formation and longevity. The galaxy's stability, despite its low brightness and minimal star formation, supports models in which dark matter acts as a cosmic scaffold, allowing large but faint structures to persist for billions of years. Even the detection of Malin 1 is a reminder of the limitations of our observational tools. For every bright galaxy catalogued by astronomers, there may be many more like Malin 1, massive, ancient, and almost invisible, waiting to be discovered in the dim reaches of the cosmos. The universe, as it turns out, may be far less luminous than we imagined, and far more populated by these hidden giants whose light barely whispers through space. The discovery of galaxies like Malin 1 has reshaped our understanding of the so-called missing baryon problem, the discrepancy between the expected amount of normal matter in the universe and what we can observe directly. In systems like Malin 1, much of the baryonic matter may exist in a cold, diffuse state that evades detection by conventional surveys. These galaxies remind us that visibility does not equate to significance. What shines brightly is often not what dominates the mass budget of the cosmos. Malin 1 also poses a challenge to galactic classification systems. Traditionally, galaxies have been sorted into neat categories: spirals, ellipticals, lenticulars, based on their morphology and brightness. Malin 1, with its faint spiral arms stretched across an immense disk, seems to belong everywhere and nowhere. Its central bulge suggests a history of structure and organization, but the surrounding haze resists simple labels. It is both structured and amorphous, active and quiescent, visible and nearly invisible. This duality makes it a subject of fascination among astronomers and a source of uncertainty in theoretical models. The environment in which Malin 1 formed is also a topic of intense interest. Unlike galaxies that reside in crowded clusters or along dense filaments of the cosmic web, Malin 1 appears to occupy a relatively isolated region. This solitude may have protected it from disruptive gravitational encounters, allowing it to retain its gas and develop at a more glacial pace. Alternatively, it might be a relic of an early epoch of galaxy formation, preserving characteristics that were more common in the primordial universe but rare today. Recent simulations have begun to reproduce galaxies with similar properties, hinting that low-surface brightness giants like Malin may first be a natural outcome in certain regimes of dark matter halo formation and gas cooling. These models show that when the angular momentum of a forming galaxy is unusually high, the result can be an extended, diffuse disk with slow star formation and low surface brightness. Malin 1, then, could represent a maximal case, a galaxy spun out so broadly that its light is forever stretched thin. There is also a philosophical dimension to Malin 1's existence. Its near invisibility speaks to the limits of perception and the importance of patience in science. For decades, its mass, its structure, and its grandeur were hidden in plain sight, not because it was small or distant, but because it did not conform to what we were looking for. Its discovery was not the result of brighter instruments alone, but of a shift in thinking, a willingness to peer deeper, to question assumptions, to chase shadows. In that sense, Malin 1 is not just a galactic anomaly, it is a symbol of humility and curiosity. It reminds us that the universe is not arranged for our convenience or immediate comprehension. There are vast structures moving silently through the void, influencing cosmic flows and gravitational dynamics, even if their light does not pierce the sky with brilliance. They are the dark dancers of the universe, weaving threads we are only beginning to trace. And so, the study of Malin 1 continues, not merely to understand one galaxy, but to probe the deeper architecture of the cosmos. It stands as a monument to the hidden majority, the unlit, the overlooked, the profound. Malin 1's structure continues to perplex astronomers, especially when considering the coherence of its rotation and the presence of spiral arms in such a low-density environment. Normally, spiral structure arises from density waves propagating through disks with significant star-forming activity, yet in Malin 1, these arms are ghostly, so faint they barely mark the boundary between organized form and cosmic haze. This suggests that even in extreme conditions, gravitational physics and angular momentum can sculpt recognizable patterns out of near-nothingness. The galaxy's massive dark matter halo, inferred from its rotational dynamics, likely plays a crucial role in holding the vast disk together. Without this invisible gravitational glue, such an extended and tenuous structure would be unable to maintain its integrity. In a universe where dark matter outweighs baryonic matter by a factor of 5, Malin 1 stands as one of the clearest examples of how dark matter can dominate not just in mass, but in shaping the destiny and visibility of galaxies themselves. Efforts to map Malin 1 in higher resolution continue, especially with new generation instruments capable of deep imaging in multiple wavelengths. Observations using the Hubble Space Telescope have revealed some of its inner structure, but its outer disk remains elusive, even to our best detectors. Future radio telescopes, such as the Square Kilometre Array, SKA, are expected to shed light on its massive hydrogen reservoir, potentially unveiling the true extent of its invisible arms and the clumps of gas that may one day ignite into stars. The faintness of Malin 1 also raises a broader concern in cosmology. How many more such giants are out there, undiscovered simply because they evade our thresholds of detection? If galaxies like Malin 1 are common in the universe's outskirts, or even in its underexplored voids, our understanding of galaxy population statistics, cosmic star formation history, and baryon distribution may be missing a crucial piece of the puzzle. These galaxies may represent an entire hidden class of structures that bridge the gap between traditional galaxies and the diffuse intergalactic medium. Astronomers are now applying advanced machine learning techniques to sift through deep survey data, searching for the telltale signs of low surface brightness giants. The goal is not only to find more Malin 1 analogs but also to understand the full diversity of galaxies in the universe, from blazing starburst systems to cold, ancient behemoths that drift in silence. Each new discovery offers a window into the wide parameter space of galactic formation, demonstrating how variations in spin, mass, gas content, and environment can lead to radically different outcomes. Malin 1 exists on the edge, not just of visibility, but of understanding. It is a relic of a quieter cosmic path, one not marked by violent collisions or explosive evolution, but by the slow accumulation of mass and the silent organization of structure in the darkness. It calls into question the bias of our instruments, the assumptions in our theories, and the stories we tell about what it means to be a galaxy. And yet, despite its silence, Malin 1 speaks. It speaks of a cosmos more subtle and intricate than we imagined. It invites us to look longer, deeper, and more carefully, to listen not only to the brilliant, but to the barely perceptible whispers in the void. As we refine our tools and expand our cosmic reach, Malin 1 continues to challenge and enrich our perception of galactic diversity. It embodies a paradox, an object so immense in scale and mass, yet so faint it remained hidden for most of modern astronomy. This contradiction forces us to confront the observational biases that have shaped our models of galaxy evolution. For decades, our understanding has been dominated by galaxies that shine brightly, form stars prolifically, and display vivid structure, spirals blazing with stellar nurseries, ellipticals saturated with old, red suns. Malin 1, in contrast, is quiet, dim, and stretched across a canvas of darkness. Yet it may be more representative of the universe's hidden majority than the dazzling exceptions we've grown accustomed to studying. There is also something profoundly elegant about the architecture of Malin 1. Despite the weakness of its light, its structure is coherent and organized. This suggests that order in the universe need not always arise from energetic processes. Instead, it can emerge from slowness, stability, and patience. The spiral arms of Malin may first be old, persistent features that have endured not because of intense activity, but because of a delicate equilibrium, a balance between gravity, inertia, and time. Its outer disk, hundreds of thousands of light-years wide, may have taken billions of years to accumulate, fed slowly by infalling gas or cooled intergalactic filaments invisible to us. Such a slow-forming giant also redefines what it means for a galaxy to evolve. In Malin 1, evolution is not a series of sudden transformations, but a gradual unfolding. It does not burn its fuel in fiery bursts but stores it across epochs, hinting at the possibility of a long-term galactic life cycle that is vastly different from that of luminous galaxies like the Milky Way. If star formation is a form of cosmic expression, then Malin 1 is a whisper rather than a roar, and that whisper may last far longer. There's also an intriguing tension in Malin 1's invisibility. It is not invisible because it is far away in the traditional sense. Its redshift places it at a distance of about 1.2 billion light-years, but because its brightness per unit area is so low. This makes it a reminder that the cosmos is not only structured by distance and scale, but by the ways in which energy is distributed and emitted. Surface brightness, not just luminosity, becomes a key factor in determining what we see and what we miss. In this way, Malin 1 offers not just a glimpse into another galaxy, but a critique of our own limitations. Its discovery also speaks to the importance of serendipity and innovation in science. When American astronomer David Malin analyzed photographic plates from the UK Schmidt telescope in the 1980s, he wasn't specifically looking for a behemoth hidden in plain sight. But by using a photographic amplification technique that could bring out extremely faint features, he stumbled upon something unprecedented, a spiral galaxy of impossible size and incredible faintness. That discovery not only unveiled a singular object but opened a whole new category of cosmic research. In the decades since, other low-surface brightness galaxies, and even ultra-diffuse galaxies, UDGs, have been identified, some with characteristics similar to Malin 1. Yet none quite match its scale. It remains the archetype, the benchmark, and in many ways, the mystery. Its discovery has triggered new generations of surveys designed to look deeper and differently, not just to gather light, but to see the shadows that light leaves behind. As our telescopes grow more powerful and sensitive, from the Vera C. Rubin Observatory to the James Webb Space Telescope, we may begin to uncover more such giants. But the challenge remains, how to distinguish the invisible in a universe biased toward the bright. Malin 1 encourages us to reimagine not only how we observe, but what we prioritize in our search for understanding. In the grand cosmic narrative, galaxies like Malin 1 remind us that not all truths are loud, and not all giants announce their presence with brilliance. Some, like silent architects, shape the universe behind a veil of subtlety. To know them requires persistence, imagination, and the humility to recognize that our senses, even when enhanced by the best instruments, may miss much of what is most important. Malin 1 endures as a cosmic monument to the hidden, the faint, the overlooked, and to the quiet majesty that resides in the margins of visibility. And yet, Malin 1 is more than a scientific curiosity, it is a testament to the universe's capacity for understatement, a galaxy whose voice is nearly drowned out by the roaring brilliance of its more luminous siblings, and yet whose scale and mystery echo louder the deeper we listen. If galaxies are the letters by which the universe writes its story, then Malin 1 is a hidden chapter, one written in the faintest ink, on the broadest page, waiting for an eye patient enough to read it. Its spiral arms, barely distinguishable from the cosmic backdrop, spiral outward like ancient brushstrokes on a fading canvas, tracing a structure that spans over 650,000 light-years, more than 6 times the diameter of our Milky Way. And yet, those arms are not ablaze with newborn stars. They are not littered with the glitter of supernovae. They are subdued, ancient, veiled in a soft blue haze of aged starlight and cold hydrogen gas, as if the galaxy itself is dreaming across epochs. It is not a galaxy that shines, it murmurs. And therein lies the fascination. Malin may first represent an alternate path in galactic evolution, one in which energy is conserved, transformation is slow, and interaction with neighbors is minimal or non-existent. In a cosmic sense, it's a pacifist. It hasn't collided violently with other galaxies, hasn't been shredded or stirred by tidal forces. It floats in solitude, far from clusters and chaos, quietly maintaining its identity for billions of years. That stillness, that stability, may be why it has endured. And it may be why it holds answers we haven't yet asked. Its colossal halo of dark matter is perhaps the most significant clue to its survival. In normal galaxies, dark matter halos help bind luminous matter together. In Malin 1, the halo is everything, dominating the mass budget, shaping the disk, and protecting its fragile stellar population from disintegration. Without it, the galaxy's vast spiral structure would dissolve under its own weakness. But with it, Malin 1 becomes a floating cathedral, an impossibly vast, dimly glowing sanctuary of dark matter and dust. Some researchers propose that Malin 1 and other low-surface brightness giants may be failed galaxies, cosmic systems that acquired massive amounts of gas and dark matter, but lacked the necessary density or external triggers to ignite vigorous star formation. They are like engines with all the parts but no spark. Others suggest that these galaxies formed early, then shut down, or quenched, before they had a chance to shine. Still others believe these are transitional forms, slowly evolving, slowly growing, building up enough mass and energy to eventually cross some invisible threshold and awaken. And what if that awakening comes? What if galaxies like Malin 1 are not relics, but seeds? What if under the right conditions, like an influx of intergalactic gas or a chance gravitational encounter, they could ignite, illuminating the cosmos with a delayed burst of starlight, like ancient lanterns finally set aflame? Such possibilities captivate both theorists and observers. For in galaxies like Malin 1, time itself becomes elastic. Evolution slows. Possibilities stretch across billions of years. These are not systems ruled by urgency, but by deep, cosmic patience. To peer at Malin 1 is to look not just at a galaxy, but at a principle, that the universe is not always in a rush, that brilliance is not the only path to meaning. It challenges our cultural bias toward the bright, the busy, the fast. It invites us to consider the invisible scaffolding of the cosmos, the dark matter filaments, the quiet galaxies, the low-temperature clouds of gas drifting between stars. In this view, the universe is not a blazing stage, but a vast, dimly lit cathedral of echoes and gravity. And in this cathedral, Malin 1 is a whisper that stretches across space and time. A monument to what can form in isolation. A map of what may await us in the dark corners of the cosmos. A question left by the universe in faint starlight, written so delicately that only now, with our newest eyes, can we begin to decipher it. It does not dazzle, but it endures. It does not roar, but it resonates. And in the quiet folds of its spirals, the story of a slower universe unfolds, one we are only beginning to understand. Perhaps the most haunting thing about Malin 1 is not its size, nor its faintness, but the realization that there may be millions more like it. Floating just beyond the limits of detection, they could form a shadow universe parallel to the one we know. A hidden architecture of titanic disks and ghostly spirals, shaping the cosmic web from the dark. For every brilliant galaxy in the Hubble Deep Field, there may be entire dynasties of giants like Malin 1, their light smeared thin across the heavens, lost to all but the most sensitive eyes. Imagine them, great silent wheels of stars spinning in isolation, untethered from clusters, unstirred by cosmic collisions, their stories stretching back to the dawn of structure itself. They are the deep forest galaxies, standing ancient and untouched while the rest of the universe blazes and burns. And Malin 1 is the first trail we found into that forest. It may even change how we interpret the past. When we look back into the early universe with our most powerful telescopes, we often find luminous, chaotic systems, the fireworks of galactic youth. But if galaxies like Malin 1 existed even then, they might have escaped our view entirely. Their light would have been swallowed by distance and dimness, their whispers drowned by the cosmic roar. We may have been reading history through only the loudest voices, while the vast, patient giants remained hidden, shaping the present from the margins. And what of life in a galaxy like Malin 1? That question, speculative as it may be, is irresistible. Would a star system in such a faint, sparse galaxy feel lonelier? Would its night sky be darker, its neighbors fewer? Or would the lack of stellar crowding offer a kind of peace, a slower clock for evolution, a gentler cosmic environment where civilizations could rise without fear of nearby supernovae or gravitational chaos? We don't know. But Malin 1 widens the stage on which such questions can be asked. There is something deeply poetic in its existence, this vast, delicate ghost of a galaxy, unnoticed for so long, now revealing itself in fragments and shadows. It is both an object of science and a symbol of perspective, of how much remains beyond our reach, not because it is too far or too small, but because we didn't think to look for it. And so, Malin 1 becomes a kind of cosmic lesson. Not everything that matters is bright. Not all giants make noise. Some of the most massive, most ancient, most influential structures in the universe are invisible to us, until we decide to search in new ways, with new eyes, and with a new willingness to question the boundaries of our perception. In the end, Malin 1 is not just a galaxy. It is a reminder that the universe is always more than what it seems. That the greatest discoveries may come not in explosions of light, but in the softest flickers of presence, in the vast, slow, nearly silent symphonies playing out at the edge of existence. And if Malin 1 is a symphony, then it is composed in a minor key, played across eons, and heard only by those who know how to listen. It defies every instinct we've developed as cosmic observers, to chase the brightest signals, the loudest bursts, the most violent transformations. It sits instead in the twilight of the universe, dim, massive, quiet, demanding a new kind of attention. Not reactive. Not aggressive. But contemplative. What does it mean to be so vast, and yet so nearly invisible? Malin 1 seems to embody a form of cosmic humility. It holds back. It exists without the need to declare itself. And yet, within its near darkness lies mass, real, gravitational, shaping the cosmos mass. Enough to warp space, to influence neighbors we cannot yet see, to anchor a corner of the universe in its silent gravity well. It doesn't blaze with youthful fervor. It abides. It's almost unsettling, in the best possible way. To realize that such structures could be the rule, not the exception. That the universe might be mostly made of quiet giants, not bright fireworks. That our entire picture of galaxy evolution, of cosmic history, might be based on a biased sample, because we've been looking only at what shouts the loudest. And so, with Malin 1 as our guide, we begin to adjust. We build telescopes that don't just reach farther, but listen softer. We design algorithms to catch the faint and the diffuse. We revisit old images and find new meaning in what once looked like background noise. Like archaeologists brushing dust off an ancient map, we start to see patterns where before we saw only static. There is beauty in this pursuit. Because Malin 1 is not just science, it's poetry written in starlight too faint to see without effort. It tells us that mystery still exists, that the frontier is not closed. That there are still places in the universe where no metaphor has been stretched, no explanation pinned down. Places that resist simplification. Perhaps the greatest truth Malin 1 whispers is this, that the cosmos does not need to impress us to be profound. It does not need to dazzle to be worthy of reverence. Its value is not in its visibility, but in its very being, in its defiance of expectations, in its quiet refusal to conform. We gaze into its spiral arms and see not only hydrogen and dust, but possibility. The possibility that the universe is deeper than we imagined. That stillness can be powerful. That the edge of perception is where the most meaningful discoveries often lie. And as we continue to map the heavens, to chart the known and unknown, Malin 1 remains there, turning silently in the dark, a galactic lighthouse for the brave and the curious, a monument to everything we have not yet seen. It waits. Not because it must, but because it can. And in that waiting, Malin 1 becomes something more than a galaxy, it becomes a threshold. A liminal presence between the visible and the invisible, between what we think we know and what still lies just beyond the veil. It asks no questions and offers no immediate answers. Instead, it compels us to slow down, to dwell in uncertainty, to reawaken our capacity for awe. For centuries, astronomy has been driven by brightness, by things that explode, radiate, flare, or burn. But Malin 1 does none of these. It is not a spectacle. It is not urgent. It is not dramatic. And yet, its existence is revolutionary. It tells us there is an entire class of objects that defy our models not through violence, but through silence. Astronomers often speak of selection bias, the tendency to study only what we can easily observe. Malin 1 is the shadow cast by that bias, proof that our vision has been incomplete. It forces us to recalibrate our instruments, our methods, and most importantly, our assumptions. If one such giant could hide for so long, how many others are veiled behind the same curtain? New surveys, like those planned with the Vera C. Rubin Observatory, are being designed not just to find what's bright, but what's barely there. These tools will widen our cosmic aperture, allowing us to trace the outlines of galaxies like Malin 1 across the sky, gargantuan, faded echoes of early universe structure formation. And when we finally map them all, we may find that the universe is not filled with scattered islands of light, but a vast archipelago of ghostly giants, forming a hidden skeleton beneath everything we see. This is the legacy Malin 1 offers us, not just data, just a new way of seeing. It speaks to something ancient within us, the desire to reach past the obvious, to uncover what lies beneath the surface. The same instinct that drove our ancestors to paint stars on cave walls, to trace meaning in patterns they could barely perceive. Malin 1 is the cosmic equivalent of a distant drumbeat in the fog. A reminder that discovery is not only about finding new things, but seeing old things in new ways. Perhaps that's what makes it so mesmerizing. It doesn't just stretch across hundreds of thousands of light years, it stretches our imagination. It demands that we consider a cosmos not built only on brightness and drama, but on subtleties, gradients, silences. A cosmos where the faintest galaxies can be among the largest, where the slowest can be the most enduring, where the invisible can shape the visible in profound, foundational ways. Malin 1 turns, quietly, in the cold dark. Its spiral arms drift like memories through the void. Its stars flicker, not in celebration, but in perseverance. It does not compete for attention. It simply is. And in that quiet existence, it holds a mirror to us. What else have we missed, simply because it didn't shine? The answer is waiting. In shadows. In whispers. In galaxies that drift like myths, half seen, half known. At the edges of everything. And perhaps that is Malin 1's greatest power, not just as an object of study, but as a question made manifest. It stands at the edge of our maps, a colossal punctuation mark at the end of a sentence we didn't know we were writing. Not a period, but an ellipsis. It forces us to ask, what is a galaxy, really? Is it merely a bright collection of stars, easily photographed and classified? Or is it something more, a gravitational presence, a rhythm of motion, a tapestry of memory woven from hydrogen and hope? Malin 1 challenges the notion that visibility defines reality. It suggests that the greatest influences in the cosmos may come not from the most visible actors, but from the invisible framework that holds the entire drama together. In this way, Malin 1 becomes a metaphor not only for the unseen universe, but for all the overlooked patterns in our lives, the quiet structures, the slow forces, the long-term orbits of thought and culture that shape who we are while escaping our immediate notice. It is the cosmic equivalent of the deep ocean, dark, immense, and full of unknown currents. The more we study it, the more it seems to echo a deeper truth, that the universe is not just made of light, but of time. And time is Malin 1's element. Every photon from its distant stars takes over a billion years to reach us, ancient light arriving from a place that may already have changed. When we observe Malin 1, we are not just seeing a galaxy, we are witnessing a fossil of cosmic slowness, a document from the age when galaxies were still stretching themselves into being. Its spiral arms are not roads, they are records. Its faint light is not weakness, it is a whisper of age. Its distance is not absence, it is perspective. And yet, the paradox remains, despite its size, despite its mass, despite its subtle pull on the fabric of space, Malin 1 is almost invisible. It reminds us that importance is not always correlated with brightness. That influence does not require spectacle. That the true architects of the cosmos may be those who work silently in the dark. For those who gaze into the sky in search of wonders, Malin 1 is both a reward and a challenge. It rewards us with its sublime existence, a galaxy too large to ignore, too faint to dominate, too strange to fully understand. And it challenges us to reimagine the cosmos not as a theater of explosions, but as a symphony of contrasts, of brilliance and shadow, of action and stillness, of galaxies that shout, galaxies that simply endure. In the centuries to come, when our instruments grow even more sensitive, when our algorithms can listen to the silence between photons, we may find the universe teeming with Malin ones. A secret scaffolding. A hidden order. Until then, Malin 1 turns on, unnoticed by most stars. A guardian of the quiet. A keeper of the slow. A monument to the unseen beauty of the cosmos. And somewhere, in that distant halo of darkness, a single ancient star still shines. Not for us, but for the gravity that holds it close. And that single star, faint, unremarkable, forgotten in the glare of quasars and pulsars, may be more meaningful than all the fireworks of the cosmos. Because it persists. Because it stays. Because it carries within it the quiet dignity of endurance. Malin 1 is a cathedral of such stars. Not a blazing temple, but a dim, ancient sanctuary where the universe has taken its time. Where gravity and silence have conspired to build something enormous, delicate, and hidden. Its spiral arms are not shouts, but outstretched hands, reaching across time, across emptiness, waiting not to be seen, but to be understood. We are only beginning to do so. As our tools become sharper, as our minds more curious, we are learning how to see what was once unseeable. With every discovery of a low-surface brightness galaxy, with every detection of faint hydrogen stretching across dark space, the outline of a second universe emerges, a dim mirror to the luminous one we've known. And Malin 1 stands at the forefront of this revelation. Not as an anomaly, but as a herald. Its very existence suggests a hidden logic in the architecture of everything. That not all galaxies were born to shine. That some were born to drift, to last, to hold memory and mass instead of light. Perhaps Malin 1 and its kin are the true ancients of the cosmos, silent custodians of the long game, galaxies that chose endurance over brilliance, time over spectacle. There is a humility in this vision of the universe. A quiet awe. The kind that doesn't knock you back with noise, but slowly pulls you inward. Like gravity itself. To peer at Malin 1 is to stand at the edge of comprehension and feel it bend. To realize that we are still at the beginning of understanding what the universe is. That the cosmos, vast as it seems, may be vaster still not in distance, but in mystery. In the number of things we have not yet learned to see. And maybe that is what makes Malin 1 so profoundly moving. It is not trying to be seen. It just is. It teaches us that some truths do not flash. They wait. So we wait with them. We build better eyes. We learn to listen in the dark. And one night, quietly, patiently, the universe will speak again. In soft spirals. In dim halos. In the still, eternal turning of Malin 1. And when it speaks, it will not be in language, but in gravity. In the slow swirl of stars around the shadow. In the echo of hydrogen rippling through the void. In the silent alignment of mass long after life has faded. Malin becomes not just a place, but a principle. A testament to what is missed when we only value what dazzles. It stands as the cosmic equivalent of deep time, unfolding not in bursts, but in drift, in patience, in persistence. In a universe obsessed with ignition, it is a study in restraint. Every pixel of its ghostly disk is a lesson. That vastness does not require volume. That presence is not always accompanied by radiance. That age can be quiet. And that the most extraordinary truths are often the ones that hide in plain sight. For what is Malin if not a relic of possibility? A fragment of a universe that might have been more subtle, more stretched, more ethereal than we ever imagined. A suggestion that galaxies are not always cities of light, they can be oceans of shadow, where time flows wide and slow. And perhaps in that darkness there is wisdom. A kind of cosmic patience. A refusal to rush. A reminder that not everything must burn bright to leave a mark. That endurance, quiet, graceful, gravitational, may be the greatest force of all. The stars of Malin do not compete with the blazing core of an active quasar. They do not pulse like neutron stars or erupt like supernovae. They are steady, faint, a whisper against the velvet dark. And yet, over hundreds of millions of years, they have continued their spiral dance, anchored by the gravity of things we cannot see, moving in the rhythm of a cosmos that respects even the faintest light. We are latecomers to their song. But we are listening now. With better ears. With wider eyes. With the humility to know that what is hidden is not lesser, only waiting. Malin continues to turn. Not for us. Not for glory. But because that is what it does. Because that is what the universe made it to do. And perhaps the deepest beauty of all is this. It would still be turning. Even if no one ever found it. Even if no human eye had ever glimpsed its pale spiral arms. Even if no telescope had brushed against its edge in a long exposure. Malin would still be there. A galaxy adrift in the cosmic dark, turning in silence, sculpted by gravity and time. That truth holds something sacred. In a universe where observation often feels like creation, where to see is to bring into meaning, Malin reminds us. Some things do not need an audience. They simply are. It is a living fossil of the cosmos. A galactic monument older than our species. Older than our planet's continents. Older than the light that reaches us now. To observe it is to reach through time itself. To touch a piece of the universe that has been turning slowly, faithfully, long before Earth ever bloomed with life. And so Malin teaches us not only about galaxies, but about ourselves. It asks, can we still wonder what doesn't beg for our attention? Can we cherish the invisible, the patient, the subtle? Can we see beauty not in fire, but in form? Not in spectacle, but in endurance? Because the universe is not a performance. It does not shine for us. It does not explode for us. It moves because that is what it does. And the greatest act of reverence we can offer is to witness it with humility. Malin is not a message. It is not a metaphor. It is not a myth. It is real. A spiral ghost in the dark. A giant veiled by time and distance and dimness. Spinning far beyond the reach of our brightest lights. But not beyond the reach of our curiosity. And maybe that is enough. Maybe the simple act of looking. Of stretching our senses to hear the quietest music of the cosmos. Is what connects us in the end to everything. To the brilliant. To the broken. To the very giants of the sky. Malin 1 continues to turn. Not loudly. Not quickly. Not for us. But still. And always. It turns. And in that endless turning, Malin 1 becomes a symbol of a universe that does not need to shout to be heard. Of truths that endure without seeking recognition. Of beauty that lies in persistence, not in brilliance. It is a galaxy, yes. But it is also a reminder. That silence has gravity. That mystery has mass. And that the cosmos is deeper, darker, and more wondrous than we ever dared to believe. We found it late. We saw it dimly. But now that we know it's there, we will never look at the universe the same way again. Malin 1. The galaxy that hid in the dark. To teach us how to see. Far beyond the familiar constellations, hidden among the distant spirals of the cosmos, lies a galaxy unlike most. NGC 4490, known as the Cocoon Galaxy, spins through space with a distorted shape and an eerie, shimmering glow. It is a place where cosmic violence meets delicate beauty, where the aftermath of a galactic collision has given birth to a stellar storm. To some, it looks like a butterfly unfolding its wings. To others, it is a broken monster, warped by gravitational trauma. But both views are right, because the cocoon is transformation in motion. Billions of years ago, the cocoon encountered a smaller galaxy, NGC 4485, and the two began a gravitational dance that would change them forever. Their close encounter didn't result in an immediate crash, but rather a slow, tidal disruption. Gravity pulled at their stars, stretching out filaments of gas and dust like threads of silk being tugged apart. Streams of material now bridged the space between them, creating a cosmic umbilical cord, a lasting scar of their encounter. As the galaxies tore at each other, shockwaves ignited waves of star formation, triggering a blaze of newborn suns in once quiet regions. That is why the cocoon glows, not from a central quasar or supermassive black hole, but from countless young stars burning hot and blue. Their radiation lights up the surrounding dust, creating a comet-like sheen that gives the galaxy its ghostly beauty. Infrared and ultraviolet images reveal knots of intense starburst activity, evidence of a cosmic nursery in overdrive. The galaxy is still reeling from the gravitational interaction, its structure asymmetrical, almost broken, but alive. This glowing trail of stellar birth is not just a sign of chaos. It's also a symbol of rebirth. In galactic terms, the cocoon is young, still evolving, still reshaping its identity. It shows us what happens when galaxies collide not in fury, but in embrace. The result isn't destruction, it's transformation. Not death, but metamorphosis. And that metamorphosis is far from over. The Cocoon Galaxy is still unraveling its story in light and motion. Its twisted arms, rich in hydrogen gas, continue to collapse into dense pockets where gravity forges new stars from cosmic dust. These stars, blue giants, short-lived and powerful, release fierce winds and ultraviolet radiation that sculpt the surrounding clouds into glowing arcs and filaments. It's a celestial forge where beauty is born from turbulence. Look closer, and you'll see something even stranger. The cocoon doesn't move like other spiral galaxies. Its rotation is uneven, its mass unbalanced, as if still haunted by the ghost of its galactic partner. The smaller companion, NGC 4485, has been dragged and reshaped into a warped remnant, still tethered by tidal streams. Together, they resemble a pair of torn wings, one bright, one fading, frozen in the slow-motion dance of gravitational entanglement. Astronomers believe this pair will one day merge entirely, becoming a single, larger galaxy. But until then, we are witnessing a moment in cosmic adolescence, awkward, luminous, and profoundly rare. Few galaxies in the nearby universe show this level of activity from such a close interaction without fully merging. That's what makes the cocoon such a compelling subject. It offers a glimpse into a fleeting stage of galactic life that lasts only a few hundred million years, a heartbeat in cosmic time. And as telescopes like Hubble and James Webb peer deeper into this glowing cocoon, they're not just observing its shape, they're decoding its past, its future, and its message. A message whispered in light that destruction and creation are not opposites, but companions. That galaxies, like life itself, must sometimes fall apart to shine. To shine, yes, but also to evolve. What we see in the Cocoon Galaxy is not a final form, but a transition caught in progress, suspended between what was and what will be. Its brilliance is not a static glow, but the flickering evidence of a galaxy rewriting itself, cell by cell, star by star. Every luminous knot of newborn stars is a declaration, I am still becoming. And perhaps that's why it captures our imagination so strongly. In its warped beauty, we see echoes of our own nature. The cocoon is imperfect, asymmetric, wounded, and yet radiant. It carries its scars openly, transforming them into luminous regions of creativity. It is not a pristine spiral, nor a stable elliptical, it is something in between. Something wild. Something alive. There's poetry in that. A galaxy torn open by gravitational tides doesn't retreat, it responds by igniting with light. It refuses to fade. Instead, it blazes with youth, even as its structure collapses and reforms. That duality, chaos and order, ruin and rebirth, gives the cocoon its strange magnetism. You cannot look at it without feeling that it is telling you something, even if only in the silent language of starlight. In deep space, silence reigns. But galaxies like the cocoon speak color and form, through disrupted arms and blazing cores. They are not static monuments, they are stories. Not in words, but in trajectories and turbulence, in spirals stretched by time, in tales of life left behind like memory. And as we gaze across millions of light years, catching the cocoon transformation, we're reminded that even in the vast, cold distances of the universe, beauty is born from upheaval. That light can rise from fracture. That a galaxy can glow like a comet, not to signal the end, but to announce that something wondrous has just begun. Something wondrous and fleeting. For the Cocoon Galaxy, like all things in the universe, is a work in motion. The brilliant starbursts we see today will dim in time. The young, hot stars will live fast and die young, collapsing into neutron stars or erupting in supernovae that scatter heavy elements into surrounding space. These explosions will seed the next generation of stars, adding layers of complexity to the galaxy's chemical tapestry. In this way, even death feeds creation. Even endings write the beginning of the next chapter. The cocoons glow, so reminiscent of a comet streaking through our skies, is not simply visual poetry, it's astrophysical evidence. A map of energy transfers, gravitational stress, and stellar ignition. Astronomers use every available wavelength, radio, optical, infrared, ultraviolet, to trace the invisible threads that pull the galaxy into its current form. And the more they study it, the more they see filaments that twist like tendons, loops of ionized gas, tidal tails that stretch for tens of thousands of light years. It's like watching a cocoon made not of silk, but of starlight and gravity. And yet, for all our instruments and models, the cocoon still resists complete understanding. Its asymmetry suggests past collisions beyond the current companion. Its starburst activity ebbs and surges with a rhythm we're only beginning to decode. Even the nature of its central regions, whether it hides a quiet black hole or simply a dense star cluster, remains a subject of debate. It is a puzzle wrapped in radiance. A question flaring with life. But perhaps the most powerful thing the cocoon shows us is this: transformation does not always follow a script. It is wild. It is unpredictable. It defies the categories we try to place upon it: spiral, irregular, barred, elliptical. The cocoon breaks the rules not to destroy, but to create anew. It is not a finished form. It is a threshold. A moment of becoming, stretched across millions of years. And in that moment of becoming, we find a reflection of ourselves. Just as the cocoon galaxy resists neat classification, so does human transformation. We are not one thing, we are many. In flux. Evolving. Torn between histories and futures, shaped by forces beyond our control, yet still capable of radiating beauty in the aftermath. The cocoon reminds us that disruption is not the opposite of growth, it is often its catalyst. That what appears broken may, in truth, be in the process of unfolding. If we could stand on a quiet world orbiting a star within the cocoon's shimmering arms, what would the sky look like? Would we see the faint streamers of starlight stretching toward the distant PGC 4485? Would the night pulse with the glow of newborn stars, too many to count, too bright to ignore? Perhaps it would feel like standing inside a cosmic storm, one not of violence, but of recreation. A storm that doesn't destroy, it rearranges. That is the deeper mystery of the cocoon galaxy. It doesn't just glow because it is active, it glows because it is alive with story. It is writing itself across the canvas of the universe, carving a signature of gravity and light into space-time. It is the butterfly emerging from a rupture. It is the monster reshaped by time. It is neither and both. And while our telescopes recorded photons from millions of years ago, what we truly receive is a lesson that transformation takes time, that beauty can rise from asymmetry, and that light, real, radiant light, often comes from places that have been torn wide open. And so, the cocoon continues to drift through the cosmic sea, a glowing fragment of galactic evolution frozen in a luminous sigh. It does not know that we are watching. It does not know that it has become metaphor, mirror, muse. And yet, it gives us everything, a glimpse into the mechanics of the universe, a canvas for the human soul, a reminder that what is deformed can still be magnificent. In some distant epoch, long after the last wave of starbirth has quieted, the cocoon will settle. It may merge fully with its companion, becoming a more stable, unified form. Its brilliant clusters will dim, its tails will fade, and its strange, radiant shape will be remembered only through the records of those who once looked up and saw more than just light. They saw motion, struggle, rebirth. And perhaps this is the true meaning of the cocoon, that even the most fleeting phases of transformation are worthy of reverence. That what we call intermediate is not unfinished, but essential. It's the hinge between states, the moment between collapse and becoming. Most galaxies live in long, quiet chapters, but the cocoon burns through pages. And we, lucky enough to witness it, are reading a rare sentence in the story of the cosmos. Because ultimately, the cocoon doesn't ask for understanding. It simply continues, glowing, spinning, changing. A whisper of stardust caught in the grand breath of the universe. It continues, not because it chooses to, but because the laws of the universe demand it. Gravity pulls, gas collapses, stars ignite, and time carries the whole tapestry forward. The cocoon galaxy is not striving for perfection, nor reaching toward an ideal. It is simply obeying the ancient rhythms written into the very fabric of space-time. And yet, in this unconscious obedience, it creates something astonishing. Something that defies expectation. Something that moves us. We study galaxies like the cocoon to understand astrophysics, how gas behaves in tidal interactions, how collisions reshape structure, how starburst regions evolve over time. But what we gain is far more than data. We gain perspective. We gain wonder. A luminous cocoon hanging in the void is not just a system of equations, it is a cathedral of chaos and light, stitched together by invisible forces, echoing with the memory of impact. And deep within those chaotic arms, beyond the bright knots of new stars, past the veils of dust, lie the survivors. Ancient stars, quiet and dim, that predate the collision. They orbit steadily, like monks in meditation, wrapped in the frenzy of a changing cosmos yet untouched by it. These stars are the memory of the galaxy before transformation, proof that continuity exists even amid radical change. They are the low-burning embers beneath the firestorm, whispering, "We were here before the storm." We endure. The cocoon galaxy, then, is not just a picture of change, it is a layered symphony. Old and new. Calm and eruption. Light and shadow. And through it all runs the thread of cosmic time, unhurried and relentless. Millions of years from now, its current shape will no longer exist. The brilliant glow we see today will have faded. But the matter, the stars, the dust, the dark matter scaffolding, it will still be there, repurposed into a new form. A new name. A new story. And what of us? We are the witnesses. Fragile beings on a small blue planet, staring through lenses and mirrors, collecting light from a distant galaxy that doesn't know we exist. And yet, from that light we craft meaning. From that structure we find reflection. We too live in cocoon phases, shifting, shedding, breaking, becoming. We too glow sometimes not despite our chaos, but because of it. Yes, the cocoon asks nothing of us, and yet it gives. It gives the gift of perspective, quiet awe, and a sense that even in the farthest reaches of space, transformation is not only possible, but inevitable. And in that inevitability, there is something strangely comforting. Because if stars can be born from the torn gas of colliding galaxies, if beauty can emerge from gravitational disarray, then perhaps there is hope woven into the deep laws of the universe. The light from the cocoon takes about 30 million years to reach us. That means we are not looking at what it is, we are looking at what it was. We see a past moment suspended in space, still unfolding before our eyes. And yet to us, it is alive. Its starlight still enters our atmosphere, still strikes the lenses of our telescopes, still activates neurons in the brains of scientists and dreamers alike. It's an ancient signal arriving in the present, a kind of cosmic time travel, reminding us that even what is long gone can still have meaning, can still shine. This alone elevates the Cocoon galaxy from an astronomical object to something almost spiritual. A fossil of motion. A monument to impermanence. A mirror held up to all things that change, break, heal, and continue. It teaches us a subtle truth that no equation can contain. The universe is not made of stillness, but of momentum. Nothing stays. Everything flows. The cocoon is beautiful because it is unfinished, because it is unresolved, because it is in flux. And when its light finally fades, it will not be gone. It will live on in data archives, in photos captured by space telescopes, in the memory of those who studied strange arms and glowing knots. But more than that, it will live on in the idea it represents, that even in the most chaotic of moments, something luminous can arise. Somewhere in the intergalactic dark, there are other galaxies undergoing similar fates, colliding, reshaping, igniting. The cocoon is not alone. But it is ours to witness now. A gift of timing, of orientation, of curiosity. And as we stare into its unraveling spiral, we find ourselves not as outsiders, but as part of its story. The cocoon evolves, and so do we. It brightens, and so do our questions. It stretches across space, and so do our imaginations. And as our imaginations stretch to meet it, we realize something profound. The cocoon galaxy is not just an object in the sky, it is a process. A slow, majestic unfolding written in the language of gravity and time. It is not a single moment, but a sequence of moments, layered upon one another like geological strata, each shaped by ancient collisions, flowing gas, stellar birth, and death. It is a story told over millions of years, and we are catching only a single chapter. What we witness as light is, in truth, memory. A memory of forces that once shaped galaxies long before humans existed. The cocoon reminds us that the cosmos is not merely a backdrop, it is the origin of all things. Every atom in our bodies was forged in ancient stars not unlike those now being born in the cocoon's glowing heart. That dust and gas, compressed by time and trauma, is the same stuff from which planets and life emerge. To gaze into the cocoon is, in a sense, to gaze into our own ancestry. And yet the cocoon is also unique. There are countless interacting galaxies in the universe, but few shine with this level of starburst intensity. Few bear such elegantly tangled arms. Few look so much like something torn and sacred at once. Astronomers have categorized it as a Magellanic-type spiral, but such terms feel too clinical for a system so emotionally stirring. The cocoon is not just a classification, it is an experience. Its asymmetry is not disorder, it is character. Its glow is not accidental, it is earned. We speak of galaxies as structures, but the cocoon defies structural thinking. It pulses like a heartbeat. It folds and stretches like breath. It does not sit still, it becomes. In it, we see not just a map of stars, but a philosophy of impermanence. Nothing in the cocoon is fixed. Its stars will fade. Its companion will fall closer. Its shape will warp. But this very impermanence is what gives it meaning. The cocoon is beautiful not in spite of its fragility, but because of it. And perhaps that is what draws us in, again and again, to these distant lights. Not just the spectacle, but the sense that something vast and real is happening out there, beyond our reach, and yet somehow deeply connected to who we are. The cocoon doesn't ask for viewers, but it receives them.